All right, we will go ahead and get started. First off, I just want to say good afternoon, everyone, and thank you so much for taking time out of your busy schedules to be a part of this backyard composting webinar. My name is Caleb Powell, and I will be hosting the webinar today for our speaker, Robert Wadley. Everyone is muted upon entry to decrease the amount of background noise, but if you have any questions, comments, or any type of problem, feel free to ask them in the chat. I'm actually sending a chat out right now, so hopefully everyone knows where that chat box is. So if you have any questions, if Robert doesn't answer them with his slides, I will ask those to him afterwards for you, and we will get those answered. This webinar is being recorded, and so everyone will have access to the recording through a link that will be emailed to you. So, Robert Wadley has worked for the Tennessee Department of Environment and Conservation's Division of Solid Waste Management since March 2006. As the department's subject matter expert for organics management, he is tasked with increasing the diversion of organics from landfills through source reduction, feeding people, feeding animals, industrial uses, and composting. He has a BS in biology from Union University in Jackson, Tennessee, and is a SWANA certified professional in composting programs. On a personal level, I thought I knew a lot about composting before I met Robert, and I, in fact, knew nothing compared to what he has, so he's got a lot to teach us today. So with all that being said, it is my pleasure to introduce my good friend, Robert Wadley.
Thank you, Caleb. So today we're going to talk about backyard composting. I hope everyone will get something out of this webinar that they can take home and use. First off, let's talk about what exactly is backyard composting. Defining composting can be challenging because it can mean many things to many different audiences, but here's some definitions that I came up with loosely based on Tennessee's solid waste regulations. Composting is the accelerated biological decomposition of organic or carbon-based solid waste under managed aerobic conditions, resulting in a stabilized product that can be used as a soil additive, fertilizer, growth media, or other beneficial use. Backyard composting is simply composting performed by a resident at the site of generation. Composting is essentially an accelerated version of nature's decomposition cycle. A tree grows in the soil, one of its leaves falls to the ground, insects and other animals eat the leaf. Some of the nutrients leach into the soil, but much of the material has to be broken down by decomposers such as fungi and bacteria. This is further broken down by earthworms, bacteria, soil mites, and fungus before it becomes an organic, rich soil which will grow more plants. Let's talk about the history of composting. Composting has a long and interesting history, and largely it's been a means of increasing agricultural fertility. Manure mixed with street sweepings was used as a soil conditioner in Mesopotamia. The process was well known and practiced by the Romans and the Greeks, again largely as a way of improving agriculture. The Bible and Talmud both contain numerous references to the use of rotted manure, straw, and other organics. References to compost are contained in the 10th and 12th century era writings, and in medieval Europe, the church was the depository of agricultural knowledge. Abbots served as agriculture extension agents, spreading what today we would probably call best management practices. It is often said that composting in the U.S. started at Plymouth Rock by the Pilgrims. However, the Native Americans had been practicing placing dead fish into the soil when they planted corn for many years before that to add nutrients and organic matter. Around the same time in Europe, William Shakespeare's Hamlet advised, "Do not spread the compost on the weeds to make them ranker." Many of our founding fathers were farmers, and they all used compost. A colleague of mine took this picture of the dung depository at George Washington's Mount Vernon. By the 19th century, composting was ingrained in American agriculture. Popular feedstocks included river muck, fish, manures, and cottonseed. The agronomist George Washington Carver once said, "A compost pile is essential and can be had with little labor and practically no cash outlay." However, agricultural composting lost acceptance due to the rise of petrochemical fertilizers, a shift from small to large-scale agriculture, increased mechanization, etc. Despite this, the 20th century contributed greatly to the science of composting. In the 1920s, the first proprietary composting system was developed in India by Sir Albert Howard. By the 1930s, Europe had its first full-scale composter, which took unground refuse and piled it into windrows. Intensive research was conducted in the 1950s and 60s at Michigan State University, the University of California, Berkeley, and also through the U.S. Public Health Service. The focus at that time was on waste management more than making a product. Today, the science of composting is well understood but continues to evolve. New applications, new technologies, and new feedstocks all present new challenges. The current trend is merging of waste treatment and agricultural interests. Urban materials are composted for eventual application to farms, although waste diversion and environmental protection continues to be a major driver of composting activities. J.I. Rodale is often credited with reintroducing American gardeners to the value of composting for improving soil quality. He established a farming research center in Pennsylvania and the monthly Organic Gardening magazine. Now, organic methods of gardening and farming are becoming increasingly popular. A growing number of farmers and gardeners who rely on chemical fertilizers are realizing the value of compost for plant growth and restoring depleted soil. By managing, so why should you compost in your backyard? By managing the material on site or generation, less energy is being used for the management of organic materials. Compost can be used to improve topsoil by increasing the organic matter content. Food scraps and yard trimmings make up about 29% of what we throw away by weight. That's not even including the other 15% paper and paperboard, some of which isn't easily recycled but can be composted, like pizza boxes. These items produce landfill gas, which is about 50% methane when landfilled versus carbon dioxide when composted. Methane is a greenhouse gas 23 times more powerful than carbon dioxide, and over a 20-year period can be 72 times more potent than carbon dioxide. So what exactly can you do with compost? You can incorporate it into your soil. Generally, you want to spread 2 to 4 inches deep and till it under. Topsoil should contain at least 5% organic matter. You can also make a potting soil with it. In square foot gardening, the soil is made of compost, peat moss, and vermiculite. You can also top dress your lawn. Plug aerating prior to this is preferred, but it's not required. You can also mulch around your plants with it, placing a 2 to 3 inch deep layer out to the drip line, but don't allow it to touch the stalk or the trunk. You can also use it for erosion control in bioretention areas, erosion stalks, and rain gardens. You can also use it for bioremediation, which is using compost to bind heavy metals found in contaminated soil. So what are the benefits of using compost? While compost isn't typically considered a fertilizer, it contains a full spectrum of essential plant nutrients. You can test your compost in soil to find out what other supplements it may need for specific plants. Compost helps bind clusters of soil particles called aggregates, which provide good soil structure. Such soil is full of tiny air channels and pores that hold air, moisture, and nutrients. In fact, composting can hold up to 3 times its weight in moisture and can reduce the need for watering. Compost brings and feeds diverse life into the soil. These bacteria, fungus, insects, worms, and more support healthy plant growth. The earthworms it attracts is especially important for aerating the soil. Healthy soil is an important factor in protecting our waters. Compost increases soil's ability to retain water and decrease runoff. Runoff pollutes water by carrying soil, fertilizers, and pesticides to nearby streams. The phrase "compost happens" is true. Organic matters decay. This is a natural phenomenon that happens with or without people. Nature disperses nutrient-rich materials abundantly. However, humans tend to concentrate them on scales far greater than nature ever would, requiring a thoughtful and managed approach to rot. That's how composting came to be. Through rigorous science and a process of trial and error, various approaches and technologies have been developed to best manage the composting processes. Here's a flow chart of the composting process. In the center, we have a compost pile, which is made of a mixture of nitrogen-rich and carbon-rich materials, often called greens and browns. Microorganisms are responsible for most of the work in the composting process. Because composting microorganisms are ubiquitous, or they're everywhere, we don't have to add them to the process. However, adding a shovelful of soil or compost can help speed the process along early on. Because compost microorganisms are living beings, we must provide a hospitable environment for them. Composting is largely an aerobic process, or occurs under the process of oxygen, in the presence of oxygen. In other words, these organisms breathe oxygen. They also require moisture and have temperature preferences. As the microorganisms work and reproduce, they produce a product that we call compost and release carbon dioxide, water, and heat. There are a lot of organisms involved in the composting process, but we're primarily concerned with bacteria, fungus-like bacteria, and fungus. This slide shows the 3 phases of composting. The first phase is the mesophilic phase, or medium temperature phase. It's between 68 and 104 degrees Fahrenheit, and it generally lasts only a few days. In this stage, the mesophilic or medium temperature loving bacteria break down soluble, readily degradable compounds such as sugars and starches. The second phase, the thermophilic phase or higher temperature phase, is between 105 and 150 degrees Fahrenheit. This stage lasts several weeks to several months. Thermophilic or high temperature loving bacteria break down the proteins and fats and work with fungus-like bacteria to begin breaking down cellulose and more resistant forms of carbon. The third stage is also mesophilic and occurs at temperatures below 105 degrees Fahrenheit. It's also called the curing and maturation stage, and it can last between 1 and several months. And this is where the fungus and fungus-like bacteria attack the most resistant compounds like lignin, and also degrade the plant toxins that are produced in the earlier stages. So how do you compost? Well, first you need to select a location. Then you need to construct a bin. This is optional. You can just do a pile, but there are benefits to constructing a bin to contain it. Then you add your organic material in proper amounts. Stir and add water as necessary. Then you need to wait until bacterial activity diminishes, and then you can cure your compost. That's optional, but it's ideal. And oftentimes you want to screen your compost as well. So what do you do? How do you select a location? It should be well drained because it will allow you to control the moisture content better. A shady spot is preferable to the sun, only prevents your pile or bin from drying out. Composting works fine in full sun. You just may have to water it more often. While on the subject of water, you want the site close to a water hose or rain barrel so that you can add water as necessary. You're more likely to compost if it's convenient, so site your pile or bin close to your house, but possibly away from, or at least downwind from your neighbors. Having it close to the garden will make it so that you don't have to carry clippings very far, as well as having a finished product close to a potential use. Bacteria become dormant when the temperatures drop below 55 degrees Fahrenheit. If properly built, the composting pile's interior will stay well above that temperature even in freezing weather. However, decomposition slows down in the wintertime, especially when we're talking about backyard composting. To achieve optimal hot composting temperatures of 140 degrees Fahrenheit in any season, a minimum pile size is required. This is often called critical mass. Otherwise, the heat generated by the initial organisms quickly dissipates before the pile can reach the right temperature for the thermophilic bacteria. A pile must be at least 3 feet in each dimension to provide the necessary critical mass. For best heating, try for a heap 4 to 5 feet square on the bottom, rising to 4 feet high. Buying or constructing a bin is optional, but it has benefits. For one, containerizing can help get the necessary critical mass with less material in less area. Also, bins can be constructed in a way to exclude vermin. Additionally, bins give you something to push against when turning the pile. Construct your bin in such a way that makes turning the pile easy, such as having an open or removable end. Pallets, cinder blocks, and wire mesh all make excellent compost bins. Of course, you can also purchase a bin, just be sure that it fits your needs. Regardless of whether you go with a pile or a bin, be sure there's enough airflow for the composting organisms to breathe. Here are some examples of what should and shouldn't be composted in your backyard. Composting feedstocks are often categorized by the amount of carbon or nitrogen. Greens are high in nitrogen, browns are high in carbon. Don't get too concerned about the color of the feedstock. That's just a generalization and there are exceptions. Livestock manure, coffee grounds, and bread are all considered greens. Paper can be pretty much any color but is considered a brown. Fireplace ashes should only be used in small amounts, if at all, because they can be too alkaline for the composting organisms. Anything that was once living or naturally produced by a living organism will compost. However, not everything is advisable to compost in a backyard system due to vermin, pathogens, and odors. Some pet or livestock waste is safer than others, but they likely all have some risk of pathogens. While we're on the subject of pathogens, this will be a good place to mention that you should practice good hygiene when working with your compost. It's always a good idea to wash your hands before putting them near your mouth, but it's especially a good idea when working in your compost, after working in your compost pile. Also, you may want to use disposable gloves if you have cuts or sores in your hands. Since some of the main decomposers in compost are molds and other fungus, you may want to wear respiratory protection, especially if you have a compromised immune system when turning the pile. You want at least as much brown material as green material, possibly 3 to 4 times as much by volume. You can add material to your pile continuously or all at one time in a batch. Regardless, you want the mix to be fluffy so that the composting organisms can breathe. Particle size can play a big role. Generally, you want a mix of large and small particles to provide proper airflow. The method on the left is an example of a continuous composting system. This is what's sometimes called the layered or lasagna method, where you alternate thick layers of brown material with thin layers of green material. The top and bottom layers should be browns. The method on the right is the batch method, where you mix the green and brown material all at once and then you don't add any more to the pile. The batch method is faster, but it's not always convenient for homeowners. There are other systems such as wandering compost pile or a 3-bin system, but they all can either be categorized as continuous or batch. The more you turn your material, generally the faster your process goes. In a batch system, you can turn as often as every 3 days. In a continuous system, you turn the freshest part of the pile after you add new material, or not. Some people just add new material and put a layer of browns on top and just leave it. A garden fork is a good tool to turn compost, but sometimes a specialty tool may work better for you. You want the compost to be as wet as a wrung out sponge, so sometimes you may have to add water to. Then you need to wait until the bacterial activity has diminished. Notice the steam in this photograph. The bacteria are still hard at work. Depending on your operation, this stage may last a few weeks to several months. So how exactly do you know if your bacterial activity has diminished? The temperature of the pile drops to near the temperature of the surrounding air. It smells earthy, not sour, putrid, or like ammonia. It no longer heats up after turn or being watered. It looks like dark soil. It is crumbly and doesn't have identifiable food items, leaves, or grass. Curing your compost lets the fungus break down some of the byproducts of the bacteria and make it safer for the plants. This can take several months because the fungus works very slowly. You can let the compost age in the field if applied in the fall, but you may want to screen it first. Screening is optional but often desired. For one, it removes the inorganic fraction like produce stickers and other plastic that won't break down. It also removes some large chunks called overs that need to be reprocessed. If you reuse the overs, it inoculates the pile with the desired microorganisms. Every compost pile, from the small pile in your backyard to the largest multi-million-dollar facility, is controlled by the same parameters: initial feedstock mix, pile moisture, pile aeration, pile shape and size, pile temperature, and compost retention time. Your initial mix should have between 3 and 4 times as much brown materials as green materials. Your pile should be as damp as a wrung-out sponge. Your pile should be light and fluffy. If you use a bin, it should have good airflow. Your pile should be 3 feet in all directions. The shape of the pile will determine how much volume that will be. For example, a cylinder is more efficient than a cube or a cone. For hot composting, you will want to achieve about 140 degrees Fahrenheit. Your pile temperature will determine how long the active compost process takes. It can take a few weeks to several months. However, it is somewhat difficult to speed up the curing and maturation stage. So here's some tips for troubleshooting your compost pile. Your materials are not decomposing. It could mean that your pile is too dry. It could be anaerobic, or it could not have enough nitrogen. So you may want to water it, or turn it, or add bulking material to add oxygen, or you may need to add more green material. If there's an ammonia odor, you likely have too much nitrogen. You need to add some brown, such as leaves or straw. If there's a rotten odor, you will likely have anaerobic conditions, or you may have just not mixed the pile very well. You will need to either turn the pile or add some coarse, dry materials. If you're getting vermin, you may want to bury the food scraps better. And that's all I have. So do we have any questions, Caleb?
I'm not seeing any in the chat. I actually have a few questions, if you don't mind. Okay. So you were talking about the benefits of having an actual bin, and I think you answered that a little bit. But so I have like a really, really small backyard, and I don't think that I would have enough area for well, I definitely wouldn't be able to just have a pile in my backyard. And I've seen in one of the pictures I saw a bin, and you said the bins usually make it where it doesn't smell. I feel like my neighbors are pretty close to me, so I wouldn't want to have, you know, but I'm guessing, you know, like you said, I guess you can add greens and stuff like that. And how beneficial is it for to have a bin that actually like turns? I've seen the ones that that have like a crank where you can turn it. Is that more beneficial or less beneficial?
Well, I generally think of those as more of a batch system than a continuous system. They definitely will work both ways, but they seem to work better a little bit in a batch system. I wonder about the airflow a little bit on the ones that turn. I made one a long time ago, and I made it myself, and it was just a little bit difficult for me to turn. It looks like a lot of the ones that you buy work better than the ones I made, but I see it more of a batch system than a continuous system. I think for a small yard, the best one is probably going to be your wire mesh in a cylinder. And if you want to to exclude vermin and stuff, you can, make a top for it out of the same type of wire. And you want the wire to be small enough, or dense enough that you don't get like mice and rats and stuff like that. I would say probably the biggest benefit for using a bin in the city is some bins exclude rodents, and I think that's probably the biggest benefit in the city. That, and you can use a smaller area. The cylinder, or even the photo, I'll go back to it, where this one here, where the lady is using, that's an earth machine. That's a continuous system, and it works real well in the backyard as well. I know you're familiar with that product, but the disadvantage to that one is you may not have a pile big enough to get hot composting, and so the process will take a little bit longer. I'm a fan of, if you can, to use more of the cylinder and mesh or even pallets, because you get better airflow, and it's a better use of your space. So if you can generate that much material, that would be the way I would go with it. But the earth machine is definitely a good product. It's just like 90 gallons or something, and it's not quite big enough to get a good heat going.
Cool. That sort of goes to my next question. I'm in a single household, just myself, and I want to compost definitely, but I just don't know if I produce enough material to actually, like you said, have enough heat to break down and stuff like that. So I'm sure that other people have that same problem. Would you recommend getting like someone like a compost company, or if you don't have a lot of material like that? I mean, I don't know how much is enough to have, a good backyard composting pile.
Well, I mentioned that briefly. There's a difference between hot composting and cold composting, but I didn't really elaborate on that. The earth machine and some of the smaller compost operations work well for if you don't have a whole lot of material. It's not going to reach the same temperatures, and so it'll be a little bit slower, and your pathogen reduction process will take longer, but you'll still reduce pathogens. You'll still produce a safe product. It'll just take longer. I'm real familiar with the earth machine. I used one. I still have one, but I don't use it that often. But I used it for about 10 years, and you can get about 2 batches a year in there, and that's a pretty good. It's a pretty good amount, but that's probably a 2-person household, so you can get about 2 batches a year with that. Another option would be more like Compost Nashville, which is an actual collector here in the Nashville area. I know Chattanooga's got Atlas Organics, and then Johnson City has Hoffman Composting, and Memphis has the Compost Ferry, and all of those pick up from residents, and they have varying charges. I would say you're probably looking at, I don't know, maybe like $20 to $30, maybe even $40 a month, just depending on where you are and stuff for weekly pickup for that. It's a completely different topic, but vermicomposting is also an option, and that's where you feed your food scraps to worms. So that's another way if you're looking at producing a product like worm castings or something similar for your garden, that's a good option. But that's beyond this particular talk, because you're really not composting, you're really just feeding worms and harvesting their manure. So it's definitely a waste diversion activity, and it will produce a product, but it's not true composting. So there's different options. I wouldn't deter anyone from trying backyard composting because if they think that they don't have enough. It just takes longer if you don't have a large pile. It's not that it won't break down.
Cool. I have a question from Mark Valencia. It says, what kind of coarse material can you use to help aerate your compost pile?
Okay. Well, there's a couple things. I mentioned that some livestock manures are safer than others. Typically, now there's some exceptions, but typically your bird and herbivore mammal and reptile are going to have safer manures for you than your carnivores like your cats and dogs. I have gerbils and I have chickens, and I use both of those litters as a bulking material or a coarse material for my pile, and it works really well. Also, wood chips, if you can get wood chips or wood shavings, that's good as well. So if you got like a wood shop and maybe a planer or something like that, and make wood shavings, that would work well. You can even use a mulch or something, buy a bag of mulch. Shredded paper works good for a while. Leaves will work for a little while, but they get compact. You can actually put whole twigs in there. Just realize that it won't break down very quickly, but it can add structure as well. There's some people even put perforated pipe in their bin to help with some aeration. That's not exactly a bulk item, but that can also help. I don't see that real often, but if you look at some of the older literature, you can see that. But I would say typically it's going to be wood shavings or wood chips.
I got another question from Guy. It says, can you start the composting process at any time of the year?
Yes. It's not dependent on weather so much. It's a little bit easier to start it in the warmer time than it is than to just start initially in the cooler. But we don't really get that cold here, and I've been to compost piles when it was 40 degrees out and the compost piles were 140, you know, so it's not really temperature dependent. It just takes a little bit longer in the winter time. The key is to get all your parameters, your process variables right, and you shouldn't have much problem. I will say if it's actually freezing, you might have a little bit of problem starting off, but I'm not in this climate. I haven't really heard of anybody having any problems starting in the winter time, but just because of when you get the feedstocks, like especially the browns, you know, fall's a good time to start with, you know, you got leaves. It's just you don't get a whole lot necessarily in the winter time. So there's no real advantage of starting in the winter, but I can't imagine any reason why you couldn't.
Cool. So, like, would you suggest getting some sort of thermometer to check the pile temperature, or I don't know, like how do you usually check that and make sure that it's near or around the right temperature?
Okay. They certainly sell compost thermometers online. I hate to endorse places, but Rio Temp is a really good brand of compost thermometers. You don't necessarily have to order it from them, but that's a good quality composting thermometer. For a commercial operation, you usually want a 3-foot thermometer, but for a home bin, they usually have like a shorter thermometer. I don't remember the exact length, but it's definitely shorter. It's between a foot and 18 inches, I believe. I don't know if it's really necessary to have a thermometer, because you can kind of tell if it's operating well. In a commercial setting, you have to check temperatures because of regulations. In a home bin, I don't know if it's really necessary. You can kind of feel if you turn the pile and there's steam, and it's hot to the touch. I mean, you know it's operating pretty well. If you look at the stages, the bacteria are different. For the mesophilic bacteria are different than the thermophilic bacteria. So when it gets to a certain temperature, the mesophilics start backing off and the thermophilics start adding on, and they like hot temperatures and they produce hot temperatures, and they're somewhat self-limiting. So I don't think it's necessary, but if you're kind of a nerd like I am about it, it's pretty neat to see that you're meeting the same temperatures that the regulated community have to meet.
All right. Well, that basically answers up a lot of my questions. I don't know. Does anybody else have any more questions for Robert regarding backyard composting? And I'm not seeing any come in. But like I said before, the recording of this webinar, along with the contact information for Robert, so if you do have any other questions, you could send those emails his way, will be sent to everyone that was registered. We really thank you for taking time out of your schedule to learn a little bit about backyard composting. It's a very good thing to do to divert organic waste from the landfill and decrease the amount of methane that goes into the air. I just got a question that says, are we able to get a PDF of the slides? Robert, I think that will be an option. I think we'll be able to send those out. Am I correct?
That's fine with me.
Okay. Well, thank you again, everyone. Thank you, Robert, for the wealth of knowledge that you bring to the table. And everyone have a great rest of the day.
Thanks.